Bismillahirrahmanirrahim. Welcome to lecture number 15 of the course CS 325 Data Science. In this lecture, we will start a new topic on how to write machine learning algorithms in Python. This is the discussion agenda. We have left only one topic in Matplotlib, and that is how to build 3D figures in Matplotlib. So we will see some examples on how to create 3D diagrams. Then we will see the seventh assignment regarding data visualization. And then we will go through the introduction to machine learning. So this is the new topic that we are going to cover in this data science course. That's how to write machine learning code in Python. So let's go to our Jupyter notebook and see the code. Okay, so this is our Matplotlib 3D. So let's go through the code and try to understand how to visualize 3D data in Python. So we first import pandas as PD and numpy as np and mpl toolkit.matplot3d. Let's import axis 3d and matplotlib.pyplot as plt and matplotlib notebook to enable figures to be displayed as inline. Let me disable the output. Okay. So now we include the IRIS dataset. Previously, in the last assignment, IRIS was not downloaded, so I downloaded the code. I make it sure that it's available to you. So this data we load using pd.read_csv in the IRIS variable, and we do plot.figure, and we do for species IRIS subset in iris.groupByName, and then plot.scatter iris subset petal length, iris subset petal width, and then we do the x label and the y label as petal length and petal width respectively, and plot.legend. So let's try to execute this code. Nothing is displayed. There is an error. Okay, let's try to understand the code. The iris.csv file. Oh, there is no name. The name is known as variety. So I think it should be here, variety. Still not working because petal length and petal width. We can do the petal.width and petal.length. So it's working. There are three different types of flower in this data set, and one category is here, one category is here, and there is the third category that is labeled as green. So this is how we can display this data in 2D, but we can make it in 3D. So let me copy the variety because we are using different variable name. What we can do is go through the iris dataset and maybe make changes there. So this is the data. It's better that we make changes here because the code is written using this data. So variety is with the name and petal dot length and petal dot width and sepal length and sepal breadth. Maybe I don't know if we are using this one. Yes, sepal length. Sepal length is here, and I think we are using sepal breadth somewhere. Probably or probably not. Just to be sure, we change it W and capital S. Okay, now it's better. Let's try to load this data here. You see it's working. And now let's see the 3D images, how to create. Still it is not 3D, it's different. sepal length is added. Yeah, it is 3D. So plot.figure, figure.add subplot 111, projection 3D, and species iris subset in iris.group by name, and sepal length, petal length, and petal width, and label is equal to species, and x-axis and y-axis and z-axis. So sepal length, petal length, and petal width, and then legend. So you see, this is how the data is displayed in 3D image. We can do some more stuff. So we have XYZ axis 3D.getTestData.1 figure plot.figure, and AX is equal to figure.add subplot 111 projection 3D, and plot wireframe XYZ and plot.show. So this is just a different type of figure. This is different than this one. You see, this is just scatter plot, and this one is different. It's like a mesh plot. This is another type, plot surface XYZ and CMap as where it is. So this is another. The above one was a mesh plot. This is with different colors. Maybe we do plot surface with the CMap this one, and with the angle we can change. So axis.view init 90 and angle and plot.drop. So this is from the 90 degree from the top, and we can change this angle. For example, we want to know 1 to 20. So this is how you can play with it. We have the third one, axis 3D.getTestData.1 and contour F. This is contour data. So feel free to play with this data and try to understand how everything is working. Try to create more examples. We will see the assignment. So in the assignment 4, this is basically your assignment number 4. So there is a case study is given, and an example is given. So this is the new data that is provided to you. So you have to load this data, and the solution to the data is given here. You eventually have to create a figure like this. So feel free to play with the code. First try to write code for yourself, and then compare your code with the code that is provided to you in this image, in this Python file. So that was Matplotlib 3D. Now we are going to start a new topic. And that is Introduction to Machine Learning. So let's see, maybe I do the slideshow. So what is machine learning? Machine learning is a study of computer programs, often called algorithms, and that can learn by example. Machine learning algorithms can generalize from existing example of a task. For example, after seeing a training set of labeled images, an image classifier can figure out how to apply labels accurately to new, previously unseen images. So this is an example of machine learning. Machine learning can be used for speech recognition. For example, if a person is talking and this is sound waves, and we give this data to some speech recognition rules, some speech recognition algorithm, and the algorithm converts the sound data to text data. So this is an example of, for example, we train first the machine learning algorithm on some different sounds and how those sounds are used to convert to text data, and then when we are given a new sound wave, we are able to convert that sound data to text data. And maybe we have not seen this sound before, but machine learning algorithm is able to convert unseen sound data to text data. So machine learning models can learn by example. So algorithms run rules from labeled example. For example, these are some audio data and this is the output data. So a set of labeled examples are used for learning is called training data. And the learned rules should also be able to generalize to correctly recognize or predict new examples not in the training set. So machine learning models learn from experience. For example, we are given some label data like email spam detector. So our email is able to differentiate, for example, it's a spam. The machine learning algorithm is built into our Gmail or email account, and it's able to distinguish between a regular email and a spam email. Machine learning algorithm can be used to understand user feedback, like clicks on a search page. So we look for the interaction of the user on a web page or on a search page, and we try to understand the feedback. We give them feedback based on their interaction with the environment. Our machine learning can be used for for understanding surrounding environment. For example, self-driving cars. So these cars are able to process different types of data from their sensors and from cameras, and based on those sensor data or images, it's able to drive without any driver. Machine learning brings together statistics, computer science, and many other disciplines. So from statistics, we are using statistical methods like infer conclusions from data or estimate reliability of predictions. From computer science, we are using large-scale computing architectures. We are learning algorithms for capturing, manipulating, indexing, combining, retrieving, and performing predictions on data. We can use software pipelines that manage the complexity of multiple subtasks. And some other fields like economics, biology, psychology, like how an individual or system efficiently improve their performance in a given environment, or what is learning and how can it be optimized, etc. This is an example of machine learning for fraud detection and credit scoring. So as an example or the data instance, we have some credit card transaction, and from these transactions we extract features like the time of the transaction, the location of the transaction, the amount in their transaction, and many other informations. We take these as feature and then we make rules. We run an algorithm, machine learning algorithm, such as naive Bayes or Cannon classifier, or there are many other classifiers, depend on whether we are using logistic data, we are using continuous data, or whether we are using some classes. So we make the machine learning algorithm is able to make some rule, and these rules give some notification, like whenever there is a fraud on the credit cards, the user is informed, the user is given a notification that an unknown or an unusual transaction happened on your credit card. And if the user confirms that the user has made that transaction, so we can inform machine learning that this type of transaction is allowed by user. But if the user denies, so we make a rule in algorithm that such type of transactions should not be accepted in the future. So this is how machine learning algorithm can be used in one case study. Machine learning algorithms can be used in different other example like web searches. So query spell checking, result ranking, content classification and selection, advertisement placement, and many more. This is an example of machine learning for speech recognition. So as the input, we have a lot of audio data, and then we pre-process those data and we extract features from that data. And we also have to label that data, like this audio signal means this text, this audio signal means this text. And then we use a decoder, and the decoder is used as acoustic model and language model. So these are different types of machine learning, like lexicon. So these are different types of machine learning algorithms that are used to extract information from the sound data. And eventually this decoder or this machine learning algorithm is able to write the corresponding text of the audio signal. So machine learning algorithms are at the heart of the information economy. Machine learning algorithms are used in finances. For example, machine learning algorithms are used for fraud detection or credit scoring. Machine learning algorithms can be used for web searches or speech recognition, or it can be used for e-commerce website like product recommendation. It can be used for email spam filtering. It has many applications in healthcare like drug design and discovery, and it has numerous applications in education like automated essay scoring. So what is applied machine learning? It means understanding basic machine learning concepts and workflow, and how to properly apply black box machine learning components and features. We learn how to apply machine learning algorithms in Python using the scikit-learn package. So this course is a beginning level course, and we will only understand the applied concepts of machine learning. What we will not cover in these topics are the underlying theory of statistical machine learning. We will not cover lower level details of how particular machine learning components work. We will not go through the in-depth material on more advanced concepts like deep learning. This is the recommended text for this course: Introduction to Machine Learning with Python, a Guide for Data Science by Andreas and Sarah from O'Reilly Media. Now let's try to understand some key concepts in machine learning. There are key types of machine learning problems. There are two different types. One is supervised machine learning. These algorithms learn to predict target values from label data. These types of data or problems are either classification or regression. Classification is used when the target values are discrete classes, and regression is used when the target values are continuous values. Let's say we have supervised learning as classification example. So we have some training data like X data. So these are our features or our sample. Let's say we have fruit detection. So this is one sample, this is second sample, third sample, and fourth sample. And we have their corresponding label, like these features, all these features are apple, and these features are, for example, lemon, and these features the same as apple. So these are per instance we have label data. So now the classifier is basically a function that maps data in the X to Y. So at training time, the classifier uses label example to learn the rules for recognizing each fruit type. Once we train the data, at prediction time, the obtained model is used to predict the fruit type for new instances using the learned rules. So once we train the classifier, we are able to make prediction on the new data. Examples of explicit and implicit label sources. For example, we have a task requester, and we label, for example, this is an image of a cat, a dog and a cat and a house and a cat and a dog. Different crowdsourcing platforms are used for this label, and then there are human judges or annotators to make sure that these images are labeled correctly. For implicit labels, clicking and reading the Mackinac Island result can be an implicit label for the search engine to learn that this island is especially relevant for the query vacation in Michigan for that specific user. So some data can be explicit to be labeled by human judges or annotators, and some data can be implicit. So that was supervised machine learning. Another type is unsupervised machine learning. And these types of algorithm basically find structure in unlabeled data. For example, it is used to find groups of similar instances in the data, like clustering. Or maybe it is used to find unusual pattern like outlier detection. So these are just two examples of unsupervised machine learning. There are many different areas and different unexplored areas, and we have developed different types of unsupervised learning algorithms that can use to find pattern in the data using unsupervised technique. For example, unsupervised learning can be used to find useful structure or knowledge in data when no labels are available. For example, finding cluster of similar users. Like for example, we have e-commerce data and we want to understand user interaction on the website. So some users maybe some quick browser, like they just quickly check some data and looking for some items or some cheap items or some deals. Some may be power users who quickly make decision, and some may be careful researchers. And these three different types of users are not labeled before, but after their interaction with the website, we are able to determine what types of users are basically visiting our website. And based on this data, we can learn how to develop or to design our future advertisement on the website to attract more users to increase our revenue. Detecting abnormal server access pattern, unsupervised outlier. For example, this is server access and the time they spend. So normally the regular user are on this pattern, but those who have malicious intent, they are of this type. So we can determine like the different server access and the time they are using to understand how to protect our server from different hackers. So this is a workflow of the basic machine learning example. So first we have representation, then we have evaluation, and then optimization, and this is a loop. We optimize, we further evaluate, then we optimize, we further evaluate, and so on. For representation, it is actually a feature representation and the type of classifier to use. Feature representation is an important area of research. For example, sometimes you have numbers, but sometimes you have text data and you need to convert that text data to numbers. Sometimes you have images and you need to know how to convert it to numbers, or sound data, and so on. So for example, we have image pixels with k nearest neighbor classifier. And then we have evaluation technique, like what criteria distinguishes good versus bad classifier. For example, percentage correct prediction on test set. And then optimization, how to search for the settings, parameters that give the best classifier for this evaluation criteria. For example, try a range of values for k parameter in k nearest neighbor classifier. So this is just an introduction to machine learning. We will continue this discussion in next lecture. For now, I think we should stop here.